Okay, so how is everyone today? Good? All right. So then, so as a reminder, 2 days from now, Friday, we're going to have a quiz. So the way that's going to work is that the quiz will cover material that is up to and including the homeworks that you're turning in today. The quiz exercises will be quite similar in structure and flavor to the homework, the written homework exercises. I'll post keys to the written homework exercises this afternoon, up to and including the ones that we turn in today. And that'll be what the quiz on Friday is over. So the quiz is going to be all lecture. So you'll come in, and instead of lecturing, I'll pass out a quiz, and you'll do a quiz. It's just like any other thing you've ever done, and it's going to take the whole the time allotted is the whole 50 minutes, and you can leave. You can leave after 25 minutes have expired if you're ready to go. Okay. Any question about any of that? All right. So let's let's get to math. So last time we left, we were just beginning to talk about square roots. So that's where we are. So specifically, what I want you to observe is something general about the structure of solving equations. So I could say, I'm going to give a sequence of examples. Suppose I say in the first example, I want you to solve for y. So, here's an example. So something like, how about y plus 13 equals x? So now this isn't a difficult equation. This isn't a difficult thing. That's not the point. What I'm going to do is I'm going to give you several examples, and I want you to see how they're structurally similar, and then we're going to introduce a new example. So what we want is I gave you an equation. So this is an equation. And I want you to respond with another equation that is such that y is all by itself. It says y equal, and then the stuff on the other side has no y's in it. So just y equal, and then other stuff that has no y. So the one that I gave you, is y already by itself? No, it's got that plus 13 there. So we want the y to be by itself. So we want the result to read y equal, and we want this, in some sense, this plus 13 to move over and be with the x. But to get the plus 13 to go over there, you can sort of think of it like, well, I'll subtract 13 from both sides. So if you subtract 13 from both sides, then there'll be nothing but y over here, and then you'll have x minus 13 over here. What I want you to see is that is this structure. It looks like this. So the plus 13, it's add 13 on that side, and then it becomes subtract 13 on that side. Oops. So it switches sides and does the opposite thing. So what's the undo for add 13? Subtract 13. Right? Okay. So I could say now, how about solve for w? So 3 multiply w is equal to 8. So again, what we want is we want the w all by itself. So it's not currently all by itself, it's with that 3. And what's happening is that that's a multiply by 3. So, we want the w to be all by itself, like that. And, it's going to go over there with the 8. And my question is, well, what's the undo button? What's the undo action for multiply by 3? Divide by 3. So getting that multiply by 3 to change sides, when it does, it becomes divide by 3. Okay? So generally, the structure looks like this. So if I say solve for doesn't matter, solve for x. If it looks like this, if we've got just some name of something that we're doing, like banana, banana of x is t. Then what you want is the whatever banana means, you want it to move to the other side, right? So, if the undo for add 13 is subtract 13, the undo for multiply by 3 is divide by 3, and whatever banana is, we'll just say that the undo for it is unbanana. So then it'll look like this. So x is unbanana of t. So this thing just moves over. But when it switches sides, it does the opposite thing. Now, to that end, here's the point, the place where I wanted to get us, is now suppose that I say the following, solve for y. Y caret 2 is x. So can you see that y is not solved for currently? It's got that caret x. And also, under normal circumstances, we don't write caret x. Rather, we just use superscripts, and that's an exponent. So my question is that, well, by analogy to all this stuff that we're writing here, if we want this caret 2 to switch sides and do the opposite thing, then we have to say what that means. So the definition of what that means is that means square root. Okay, so now we're going to write down the exact definition of it. Okay, so this is called square root. Okay, so now I can say let x and y be in the reals. Then TFAE. So this will be the last time that I remind you what that initialism means. So TFAE stands for the following are equivalent. So, to be clear about what I mean, so every specialized profession has like lingo, special vocabulary words that go with it. Mathematicians are no different. An example is like doctors, physicians, medical doctors. So if if today you trip and fall, that wouldn't be good. And suppose you do that and you injure yourself and you get a big cut. And you've got to go to hospital, and the doctor is going to sew you up, right? So then on the street, non-medical folk usually will say something like, well, I had to get some stitches. And that's a good word for that, more or less, because, our clothes and other items like that are stitched together. But in a medical setting, those aren't called stitches. What are they called? Sutures, right? Because, they have their special names. I'm not sure why I'm sure they have a good reason, I just don't know what it is. At any rate, what I'm saying is this kind of thing, the following are equivalent. This is a math thing. So specifically, what I'm saying is that, it's like, I'm trying not to make it blow out. Okay, so there's an equation, and I said I want you to solve for y. What you had to do was produce a second equation, like that. So what that means is that these are equivalent. They mean the same thing. Okay. Similarly, here, I gave you this one and said, I want you to solve for w, and you had to come up with an equivalent situation. So that's equivalent. They mean the same thing. So what I'm going to do right here is I'm going to write two things that mean the same thing. So first is that y squared is x. And of course, you know, I'm writing it as an exponent, like that with a superscript. But do remember that that's caret 2 is what it is. So now this next bit is I'll just say this. It's my experience that many students come here knowing about square root, but they don't know the whole story. There's some gaps in their knowledge, and this next thing I'm about to write is one of those gaps. So y squared is x, and y is greater than or equal to 0. So that's one situation. So that situation is the same as this. So I want to solve for y. So you know I want the caret 2 to switch sides, and when it switches sides, the way that it is written down is like this. So like that, and that's called the square root of x. So what I'm saying is that you know this caret 2, when it switches sides, it does that. All right. So a couple of comments about this. So first note. From 1. You know, if 1 is true, just switching the sides of the equation, we know that this is true. That's just, you know, just putting it the other way. So what we're saying is that x is some number squared. And now here's something that I want you to observe from that, and that is that, well, y can be, you know, this says y has to be greater than or equal to 0. But even ignoring that, let's imagine, what if y is positive, and then we square it? The result would be positive, right? So if you take a positive number and you square it, you get a positive number. What if y is negative, and you square it? You get a positive number. And so if you square a negative number, you get something positive. If you square a positive number, you get something positive. And we've eliminated almost all the possibilities. What's the last possibility? A number that is not negative and not positive. 0, right? So what if you square 0? What do you get? 0. And so do you observe that if I give you a real number, y, and then you square it, it is not possible for you to get a negative result. Okay? So the result's going to be 0 if you're squaring 0, and otherwise it's going to be positive. Okay? So from that is that, and so we can say therefore x, in fact, is greater than or equal to 0. Because x is something squared. Okay. So now let's use the definition a little bit. If you've seen square root, it's you know, very similar to what you know already, and we're going to go through the pitfalls. Okay, so then for example, I could ask, well, what's the square root of 16? 4. Okay, so that's the correct answer. Now, the most common incorrect answer, so this is good, yes. The most common incorrect answer is this, to say the square root of 16 is plus or minus 4. So that's wrong. Okay, now there's a couple reasons why this couldn't possibly be correct. Now, the first reason why is that square root is like a machine that you give it one input and it produces one output. So you can like imagine if well, like some fancy places like Facebook and Google to work, you know, some places like that. I hear that they have like vending machines where you don't have to put money in. Like if you just want a snack, you just go over and just press the button. That's cool. So just imagining that for a moment. If you go up to the vending machine and you press the button, how many things come out? One thing. That's the way square root works. So qualitatively, this is not right, because you're saying that if I push button 16, then two things come out. -4 comes out and a +4 comes out. That's not the way it works. Only one thing can come out. Okay, so this answer couldn't be the correct answer for that reason. Now, then you might say, okay, well, one thing, I'll accept that for now, but then why +4 over -4? Why are we biased in that way? Okay. So here's the reason, is that so note. So what I did is I said, I want you to tell me what the square root of 16 is. So I could say, well, I'll just write that this is equal to y. And I want to know what y is. So that's just giving another name for it. I say, well, I want to know what y is. Now I could solve for 16 and say that 16 is equal to, and effectively what I'm requesting is that I want the square root to go to the other side. Okay, so just like this, subtract 13 can go to the other side as add 13. Divide by 3 to the other side as multiply by 3. If I want the square root to go to the other side, what does it become? Y squared. Now, more or less, my experience is that this is where it ends in high school, or whoever taught you before you got here. But this is not right, because have a look at the definition. Two things are equivalent. So if you write this, you're saying that this situation is equivalent to that situation. They're not. What's being missed? That's being missed. That one. See if I can get this to line up on the pages here, so that when you look at, if you ever happen to look at the course notes, you can see it. All right. So now the question is can you tell me a y that I can square? If I forgot that part, it would be asking, can you tell me a y that you square it and you get 16? Well, in fact, there's two choices. If you square 4, you get 16. If you square -4, you get 16. If that was the whole story. But it's not. It's actually that I want a y so that I square it and get 16, and moreover, that y can't be negative. So now there's just one choice. And what is it? 4 only. Right? So this one, by itself, is saying y is -4 or y is 4. And then when you also add this one in, we can say, therefore, we're talking about y is 4 only. Okay? So the square root of 16 is 4, not plus or minus 4. And I'm not disputing that you can square -4 and get 16. Of course, that's true. Nevertheless, the square root of 16 is 4. So I could ask, well, how about the square root of 36? So this is straightforward. What will it be? 6. So the square root of 16 is 4. That's nice. The square root of 36 is 6. That's nice. What about the square root of 2? Is that a thing? Well, here's the deal, is that square root of 2 is a number. Now, it's not an integer. The square root of 16 is nice in the sense that the square root of 16 is 4, and that's an integer. And the square root of 36 is nice in the sense that the square root of 36 is 6, and that's an integer. Now, the square root of 2 is a number. It's not an integer, but it's still just some number. And, you know, to the first two decimal places, two places past the decimal, it's about 1.41. 1.41 ... is not equal to 1.41. I'm just saying I wrote the first two there. And, you know, you could verify that on your calculator. So the way to get this calculator to do it is that you can see a square button there. So if I wanted to square, I could press that button, and then just very faintly above it, you can see the second feature of that button. So if I press second and then that button, you can see it prompts me with the square root symbol. And then with 2, and then blah, blah, 1.41, something, something, something. All right. What is the correct response to this? The square root of negative 16. Yeah, this is undefined. It's undefined because if you look back at the definition, we said note what we're saying is that condition 1 implies that x is greater than or equal to 0. And look, x is the thing that's in the square root. So there is no definition for what you do for a negative input. It's undefined. You can't do it. So the correct answer is to say it's undefined. Now, if you don't like definitions that much, then you could say it like this. You could say, well, I want to consider the square root of negative 16, and I don't know what it is, so I'm going to call it a w. The only reason why I'm writing w is I just don't want you to get too emotionally attached to y or x or whatever. So if I want to get, if I want to do the same kind of thing, move the radical around and solve for the negative 16, then the resulting equation would read negative 16 is equal to what? W squared, and moreover, what needs to be true?
W is greater than or equal to 0.
Yes, and W is greater than or equal to 0. Now, on this example, that part doesn't actually matter. I'm just reminding you about it. So now, just having a look at that, now the question has been restated. First, I was asking, what's the square root of negative 16? Now, here's an alternate way to ask the question. Please tell me the real number, W, that I can square and get negative 16 as a result. So could I square a positive number and get negative 16? No, because when you square a positive number, you get something positive. So W couldn't be positive. Could W be a negative number? No, because when you square a negative number, you get something positive. So W couldn't be negative. So we've eliminated almost all possibilities. What's the last possibility?
Unreal number.
0 is the last real number. And so 0 squared is 0, and it's not negative 16. So there's no W that does this. There isn't one. Okay, so it's undefined. Now, to that end, I'll just let you know that in math and science and things like that, it's very important to pay attention to when something is undefined or defined, or something exists or something doesn't exist. Because the thing is that you know, in the case that you're talking about things that don't exist, anything that you say about things, or generally sets of things that don't exist, your statements about them are true. So here's something that is true in the sense of math and science and logic and things like that, but nevertheless, from a human point of view, something is funny about it. Okay, so here's something that's true. Are you aware that UTD has won every national football championship we've ever participated in? We have won every one of them. In fact, we have never lost a single football game, so we're undefeated. So, are those statements true? Are they correct? Yeah, they're correct. They're true. But you know, from a math point of view. But now from like a human point of view, what's not being said? We don't have a football program. We don't have a football team. We've never had a football team. We haven't played any games. So now you might say, well, doesn't that mean that what you're saying is not true? That's not what it means. That's what I'm saying is true. Because I say, we've never lost a game. And you say, that's not true. Then I say, really? Could you show me the game that we lost? Your inability to produce such a game means that what I'm saying is true. Okay, that's disturbing. But do understand also that it is just as correct to say that we've never won a game. And it's also just as true to say that we have lost every national football championship that we've ever participated in. Moreover, at every national football championship that we ever participated in, at halftime there was a purple giraffe doing cartwheels at you know, in the middle of the field. That's true too. So what I'm telling you is that you know, you have to be very careful on such things. So it's not a little thing to say that square root of negative 16 is undefined. It's an important thing to know. Okay. Fine. But before I do that, I'm going to say one thing, and that is that notice that when we do this action, when we say y squared is x, and we say, well, I want to solve for y and get the square to move to the other side, when it does, it looks like this, square root x. You know, and you got to remember the inequality bit, so and y is greater than or equal to 0. So what I want you to observe is that, you know, that's a caret 2. And then this symbol here, this thing, its name is radical. So that's the name of that shape, radical. But notice that there's like no 2 over here. So that's as opposed to like this. So notice we had multiply by 3, divide by 3. So I see a 3 there, I see a 3 there. So, you know, that looks good. I see a, you know, add 13, subtract 13. I see a 13, I see a 13, that's good. But here, what I want you to observe is that I see a 2, I don't see a 2. Okay. Well, you usually don't write it, but sometimes for emphasis, I will write the 2 right here. So now, 2, 2. Now, the reason why I'm going to do that is because, you know, if we can move caret 2 over, then why not move caret 3 over? Or caret 33, you know, if we want that to move over. So when it moves over, we've got to keep track of the exponent, and that's the place where you write it. Now, I'm just telling you that under normal circumstances, you don't write the 2 there. It's just understood. But if you're talking about other exponents, then you have to write it. Okay. Now, before I say the next thing, I'll remind you of a word that you know. So parity. So we had to talk about parity on the very first day so that we could understand how to turn our homeworks in. Oh, we didn't turn the homework. Well, we'll do it at the end. I forgot. So parity. You know, we're supposed to turn in even homeworks at the beginning and odd ones at the end, but I evidently forgot. No, I did. We did, right? And then I just moved it. Okay, good. I thought I was losing my mind there. So we turn in even ones at the beginning and odd ones at the end. Okay, so then, so every n in the naturals has parity. Again, that's just even or odd. So even, the even ones are 0, 2, 4, 6, ... and the odd ones 1, 3, 5, 7, ... And what I want you to observe, what I want you to note, is that on the previous page we were talking about square root, which is like the undo for caret 2, and 2 is even. And now we're going to talk about the undo button for caret 3, and 3 is odd. And the behavior is going to be different, and the reason why it's going to be different is because of even versus odd, because of parity. So this one is called cube root. So let x and y be in the reals. TFAE, the following are equivalent. So the first is that y cubed is x. So, you know, instead of y squared is x, y cubed is x. And now, when we were talking about square, we had that inequality bit right here that I've pointed at so many times. There is no inequality here. There isn't one. I'm not forgetting it. It's not there. And just to make sure that you understand that I'm not forgetting it, I'm going to write here that y can be any real. So I didn't forget it. It's just not there. That one is equivalent to this one. So we want to solve for y. Okay, and when the caret 3 moves over, it moves over and looks very similar to a square root, except we can't, you know, this isn't right currently. So we need to remember that, oh yeah, it came from exponent 3. So what do? We write the 3 right there. Okay? Okay. So notice that there's no inequality condition. So for example, I could ask, what's the cube root of 8?
2.
It's 2. Now, when you have become comfortable with this, you know, you just rattle it off. But I want to make sure that you know, you understand exactly why this should be the case. So why? Well, in the first place, do you agree that we've already talked about what exponents are, and that we know what that means? 2 to exponent 3. That means make 3 copies of 2, so 2, 2, 2. And then what are we supposed to do with all of them? Multiply them together. So what is 2 times 2 times 2? It's 8. Okay. Now, so, you know, understood? Then I could say, well, concerning cube root of 8, I want to figure out what that is. So suppose that I give it a name, just so I can refer to it symbolically. So how about I give it the name, I don't know, b, just because I don't want you to get too attached to x's and y's and things like that. So that's a b. And if I want the cube root to change sides and leave the 8 there, then it would read like this. It would read 8 equal, and then when the cube root changes sides, what does it become? B cubed. So b cubed, like this. So the cube root changes sides. And now, you know, asking the question like this, I could say, what's the cube root of 8? Okay. Alternatively, I could say, please tell me a number that I can cube so that I get 8. Well, 2, right? Okay. Okay, so how about this one? How about I ask about the square root? So I'm asking about the square root of negative 8. What's the correct response? This is undefined. It doesn't exist. Either one. You can write either one. All right. How about this one? How about the cube root of negative 8? It's negative 2. So here I want to point something out to you, and that is, you know, the purpose of me asking this one is for you to look at a radical, and I give you, I give you a negative input, and you're supposed to say, oh no, we can't have that, can't put negatives in there, and then to give you this radical immediately afterward, that with the same negative input, and then suddenly it's permitted. So this is negative 2. So not only is it permitted, but you just calculate it right there. That's what it is. Now the reason why is that if you take a negative 2 and you cube it, just following the rules. That means make 3 of those negative 2's. And multiply them all together. So if you take the first 2, negative 2 times negative 2 is positive 4. Then you multiply by 1 more, and you get a negative 8. All right. So any question about this one? So so what I want you to see is that it's fine to give negative inputs to the cube root, but not to the square root. All right. So now, to do the next thing, we have to take a sort of a hard turn for a moment. Something that's not going to seem like it really fits in this place. So there's a thing called absolute value. So the reals can be drawn as a number line, can be plotted as a number line. So usually, in most circumstances, you point out where 0 is. The arrow pointing to the right means that that's the direction where things are getting bigger. So the numbers are getting bigger as you move to the right. The numbers are getting smaller as you're going to the left. Stuff that's to the right of 0, that's the stuff, that's the positive stuff. Stuff to the left of 0, that's the negative stuff. Now, concerning the reals, so 0 is sort of by itself, but every other real number has a pair. It comes in a pair. So, for example, we have 2 5s, 2 kinds of 5. We've got positive 5, and what's the other kind? We've got negative 5, right? So every real number, comes paired in this kind of way. So you've got who's paired with negative 9? Positive 9, right? So then absolute value, what it is, it's saying that, well, if you input 0, the output is 0. And if you input anything else, the output is the positive one. So like the absolute value of 8 is 8. The absolute value of negative 7 is positive 7. Right? It's a positive one. So that's what absolute value is. But we want to have a nice definition. So you can think of absolute value as just a thing that basically always picks that one out. It picks the positive one. But here's the definition. Absolute value of x is, so that's a big, on the keyboard you've got like 3 kinds of parentheses. You got the round ones, they look like this, like the round kind. Yeah. And then you got the square kind, squarish kind, like that. And then you've got the last kind that looks like this. That's just a big one of those. They all have names, but I try not to. No one seems to remember them, so I just call this one a parentheses, a square parentheses, and a curly one. But the names are actually parentheses, bracket, and brace. Whatever. So, big brace there, and then now I'm going to write 3 lines. So, the absolute value of x is negative x when x is negative. It is 0 when x is 0, and it is just regular old x when x is positive. So what that is that's 3 different conditions. We're going to do one of 3 things, and the thing that we do depends on what was put in. Okay? So these individual things, these individual lines, the name for them is called clauses. And they're numbered top to bottom, starting with 1. So clause 1, clause 2, clause 3. And then to evaluate absolute value, it's just you just need to figure out which clause you're supposed to use, and then you do it. So for example, the absolute value of 5. So it's good to have a mental model of how it works, but we're going to just follow the definition. Okay, so then I entirely expect you to know that the answer is 5. But I want to be clear about why the answer is 5. So the definition is saying that the input is x, and when the input is negative, that's what you do. When the input is 0, that's what you do. And when the input is positive, that's what you do. So the input is 5. Which clause are we using? Clause 3. And clause 3 says that when the input is positive, the output is the same as the input. So you just copy it over. Just blah. So that's the answer. Okay, so nothing mysterious there. All right. What's the absolute value of -4? So in the first place, which clause are we using? We're going to use the first clause because the input is -4, which is negative, and clause 1 is saying that you do that when the input is negative. So we use clause 1. We'd use clause 1, and we'd get -4, right? Because you're supposed to take the input and then put negative. Now, of course, under normal circumstances, you wouldn't write -4. You'd just write 4. But I want you to see how the definition works. All right. How about what's the absolute value of -11? So which clause? Clause 1. And then what's the answer? Very good. And I'm just going to write 11. And I chose that one there because, so now that you've probably had time to write that down, I want you to look, and if you wrote something that looks like this, you need to stop. That is not acceptable in this class. Your ones and your absolute value bars must look different. Okay? How about this one? The absolute value of 3 minus pi. Now, I don't want decimal places or anything like that. I don't want anything like that. I want the exact answer. So again, it's a matter of definition. There's 3 different clauses. One clause says what to do when the input is negative. The other clause says what to do when the input is 0. The other clause says what to do when the input is positive. So all that's necessary is we just need to figure out, the first thing we need to figure out is which clause are we going to use. So the input is 3 minus pi. Is that negative, 0, or positive?
Negative.
It's negative, right? Now, why is 3 minus pi negative?
Because pi is greater than 3.
Right. Pi is about 3.14-ish, more than 3. So, you know, concerning this, pi, starts out with 3.14, ... and therefore, 3 minus pi is negative. Well, that tells us which clause we need to use. Which clause? Clause 1. We have to use clause 1. And clause 1 says that you just, whatever the input is, you just write the input and put a negative sign in front of it. Right? That's what it's saying. So we'll just write the input and then put a negative in front of it. But that's almost right. It's not right. How do I fix it?
Parentheses.
You have to have parentheses around it. Because the input's negative, the output is negative, whatever that is. And then, when you get accustomed to doing this, you would write this as pi minus 3. The reason is because if you have a subtraction, a minus b, if you do a subtraction, and then you take that subtraction and you negate it like that, then the result is another subtraction, but in the opposite order. It reverses the order. So a minus b becomes b minus a. So putting that negative there turns the 3 minus pi into pi minus 3. Any question about this one? So now, I want to point out that for a while I was talking about radicals, and then suddenly I started talking about absolute value, you know. I promise I have a reason, and here it is. So I'm going to call this remark do and undo. Almost. Okay. So first, suppose I have some w. I've got a w there, and then I say, hey, let's take that w and multiply by 3, and then right after we've done that, let's divide by 3. Then what will we have when we've done that? W. Because, you know, that's just a fancy way to say, let's take that w and do nothing. Let's just leave it. Right? Just like that. Okay. What if I take a z and I say, hey, I got an idea. Let's subtract 5, and then immediately after we've done that, let's add 5. What will we have? Z. Okay, so it's all, you know, it's working, right? And I don't intend there to be anything surprising about what I've written here, other than you might not see where I'm going with it. So now we have squaring and we have square root. And my experience tells me that if you've heard about square root before you got to this class, you're under the mistaken impression that you think that they undo each other. They do not. They don't because of that inequality. So, if we take an x, and the first thing we do is square it, and then immediately after we square it, we compute the square root of the result, what do we get? Now, if they really did undo each other, what would you get?
X.
You'd get x. But that's not right. What do you get? What were we talking about on the previous page? You get the absolute value of x. That's what you get. These absolute value bars, sad to say, that I've taken so many points away from college algebra students for those absolute value bars, because of the mistaken idea that that you square something and then compute the square root and you get the same thing back. Now, to be clear, here's an example of it working the way that you won't be surprised by. So if we take a 4, and I'm putting the things in order so you can see it. So suppose we take a 4 and we square it, then what do we get?
16.
A 16. And now suppose we take that 16 and we compute the square root. What do we get? 4. So what I'm saying is that this is an example of no surprise. Right? You started with a 4, you did it, you undid it, you ended with a 4. What if we take a -5 and we square it? What do we get? 25. And then now, let's compute the square root. What do we get? 5. I claim this one is surprising because we did it and we undid it, but the input and the output are not the same. We started with -5 and ended with 5. Those aren't the same. And do you observe that there's really actually nothing special about 5? I could have done -6. It would have been -6, 36, 6. -10, 100, 10. So what I'm saying is that this kind of thing, you square and then square root, what it does is it takes pairs of numbers and picks the positive one. What is that?
Number 1.
It's absolute value. Okay, now here's the thing that'll disturb you, and this will be the last thing that we say today. here's the last thing. So square root of x, so you take x, you square it, and then compute square root. That's absolute value. Now, normally, under normal circumstances, you don't write square root's name because it's so important in such a, you know, such an important thing. It doesn't even need a name, right? But you know, there's an implied 2 right here. Now what I'm saying is that, hey, you know, we have a cube root too, right? Suppose that we write this one. The cube root of x cubed. What's the answer? So in the end, the question is, you know, so we're saying that square and square root don't undo each other. How about cube and cube root? They do. They do. Because we could say -2, let's take it and let's cube it. What do you get if you cube it?
8.
Not 8.
No, sorry,
-8. And then let's take -8 and let's compute its cube root. What do you get? -2. Huh. So these really do undo each other, but these do not. And this discrepancy, I'm telling you, I'm warning you now, I'm going to talk about it all semester. Lots of students lose lots of points because of that. And the rest of the radicals, where we want to shift an exponent over to get a root, the even ones will all behave like square root. And the odd ones will all behave like cube root. And this even odd business will be all over the semester from now on. Have a nice Wednesday.